Okay, today we're learning division properties of exponents, and we're going to start with quotient of powers. Yesterday we learned about product of powers, and that was when you multiply powers of the same base. When we multiplied powers of the same base, what did you do with the exponents? When you multiplied? Added them, right? So with dividing powers with the same base, you're going to subtract. So that example I have there is a to the 11th power over a to the 8th power. So you take, they have the same base, they both have base a. So you take a to the 11 minus 8 to get a to the 3rd. All right, let's look at a couple examples with this. On number 1, we have g to the 3rd divided by g. What is the exponent on the bottom one? I think I heard it. Did you say 1? Good. So they have the same base, g. What do I do with the exponents when I'm dividing? What? Subtract. G to the 3 minus 1. So what's our new exponent? 2. Yep. Again, you don't have to show this step. I'm just showing it since it's your first time seeing it. Hey, what about number 2? What do you notice about number 2? There's 2 different like terms, right? So, just like multiplication, we can split it up. We have x to the 3rd divided by x squared times y to the 4th divided by y. What's the exponent on that second y? 1. Now just take it one at a time. What's my new exponent for x? 1. And then what's my new exponent for y? 3. So all I did was I subtracted. And that is my new answer. So same thing with multiplication. You can split them up into like terms. Okay. Any questions on dividing powers of the same base? Okay, let's look at power of a quotient. So yesterday we did power to a power. Same thing here, except it's in a quotient. So you're going to take the power of the numerator and the power of the denominator. So power of a quotient, think distributing, you're taking that power to the numerator and to the denominator, to every term, just like we did with power to a power. So 3 over 5 to the 4th power turns to 3 to the 4th power divided by 5 to the 4th power. So what happened is this exponent went to both. And remember, when you take those powers inside the parentheses, they stay as powers. They don't turn into numbers. They stay as exponents. We good to move on? Okay. So let's try a couple examples. What do you see on number 1? I wrote that completely wrong. Give me 1 second. All right. Now what do you see on number 1? We have a quotient to a power, right? Take it to both. Okay, so I'm going to take that that exponent to the numerator, and I'm going to take it to the denominator. So I have p to the 3rd power divided by 2 to the 3rd power. Remember, when you bring those in, they stay as exponents. Okay, so how can I simplify this farther? Can I simplify p to the 3rd? Nope. Can I simplify 2 to the 3rd? To what? It is 8. Yep. Good. Number 2, we got a little more going on. What do we think? What am I going to do with that power on the outside? Take it to every term. Okay, so when I take that to the 3, it is not 3 times 2. It is still 3 squared. Okay, what would my new exponent be on the x? Right, because we're taking a power to a power, so I have x to the 8th. Good. Now I'm moving on to the bottom. What do I get on the bottom? 4 squared. And then what's my new exponent for y? To the 4th. Yep. And then can I simplify that at all? The numbers, right? What's 3 squared? 9. X to the 8th. What's 4 squared? 16y to the fourth. Good. So quotient to a power is the same thing as same thing as power to a power. It just has two different steps. Okay, any questions so far with those? Can I move on? Okay. Simple question, what do you notice? Okay, what's 2 to the third power? 2 times 2 times 2 is 8. Okay, what's 2 to the second power? 4. What's 2 to the first power? What's 2 to the 0 power? I hear 0. Any other ideas? What's happening every time you go down?
2.
How do I get from 8 to 4? Subtract 4. Okay. How do I get from 4 to 2? Subtract 2. Do you notice a pattern? There's a different pattern we should see. What's a different way I can get from 8 to 4? Divide by 2. How do I get from 4 to 2? Divide by 2. How do you think I get from here to here? Divide by 2. What's 2 divided by 2? 1.
Oh, dang it.
Anything to the 0 power is 1. Anything. Any number to the 0 power is just 1. Okay, did I just blow your mind? Okay, go ahead and write this definition down. So 0 exponent property is any number raised to the 0 power is 1. Whenever you see the power of 0, do not think too hard, because what should you just put? 1. Okay, let's look at a few examples with the 0 power. Here, we have x to the 5th times y to the 0 power over x to the 3rd. Well, what do we know about y to the 0 power? It's 1. So we just have x to the 5th divided by x to the 3rd. Does everyone agree with me there? Because it would just be times 1. How can I simplify that farther? Right, because we have common bases. So we can do what with our exponents? Good. 5 minus 3? 2. Okay, what about number 2? Does it look like a hot mess? Okay. What do you see, though?
Oh,
It's 1. Anything to the 0 power, even if it is this messy, it is 1. Anything to the 0 power is 1. Okay, and since if we followed what we normally would do, we would take this 0 into every term. Every term would equal out to 1. That's why you can just assume the whole thing is 1. I just had to point that out.
Said I can't.
Okay, any questions with the 0 property power? 0 power property. There's one more thing we have to talk about. And it's another what do you notice? So what's 2 to the second power? 4. 2 to the first? 2. 2 to the 0? So we said every time what's happening? We're dividing by 2. So how do you think we get 2 to the negative 1? Divide by 2. So what's 1 divided by 2? 0.5, which is 1/2. Okay? So what do you think 2 to the negative 2 is? So 1/4. What do you notice between 2 to the second power here to 2 to the negative second power?
The same denominator to the numerator.
There's a word for it. You have the right idea. So one of them is 4. One of them's 1/4. They are, starts with the R. They are reciprocals of each other. So if I see 2 to the negative 2, negative exponents, you cannot have those. So to make them positive, they move to the bottom. And that's how they get that 1/4. So negative exponents, you do not want them. You want to move them, the reciprocal of them. Okay? But let's look at examples with that. So negative exponent, the definition they had was terrible. I didn't put one. Okay? Just put reciprocal. That's what I want you to put. Reciprocal. So 2 to the -4th. We don't like negative exponents, so we got to move them to the bottom. So we move that whole base to the bottom. So we have 1 over 2 to the 4th, which gives us 1 over 16. And whenever you see a negative exponent, you want to move that to the bottom. Examples. Number 1. Okay? I just heard a pfft. Did I hear that from somebody? Okay. Separate it out. So I have n to the 5th, right? N to the -5th. And I have p to the 4th. And then I have 1 over r to the -2. Do you notice how I did that? Since it's on the bottom, I just put a 1 on the top when I separated it. So all I did was separate out what I have. Now let's simplify one by one. So n to the -5th. What do you notice about n to the -5th? It's a negative exponent. I want to make that exponent positive. How do I do that? Flip it. 1 over n to the 5th. Because right now, it's n to the -5th over 1. I just want to flip it, the reciprocal. Okay? What about p to the 4th? Do I have to do anything with it? Nope, keep it. So I have p to the 4th. And I'm just going to put over 1 to remind myself. Now, what about that last one? 1 over r to the -2. What? Do we like negative exponents? Want to get rid of the negative. How can I get rid of the negative? Flip it. Reciprocal. So I have r to the 2nd over 1. So when you flip it, that exponent becomes positive, no matter which way you flip it. Now let's just put it all back into one fraction. So what do I have on the top? I didn't record any of that. That's okay. I'll record this one. Number 2. What do we notice about number 2? Hot mess? Okay. What can we do if we think it's a hot mess? How can we make it easier on ourselves? Separate it out. What can I put together? I heard you're both right. I'm just going to work left to right. What can I put with that 5? -20. Yep. I heard the r, so I have r to the -3 on the top. What do I have on the bottom? R squared. On the top, next, I have t to the 4th over t to the 7th. And then what is my other grouping I need to make? What's on the bottom? U to the -5. What can I put on the top since there was nothing there? 1. Yep. So all I did there, I didn't change anything. I just separated it all out into their like terms. Now we got to use our different properties. What can I do with 5 over -20? Can I simplify that? Did I hear a yes? How can I simplify it? Yep, divide both of these by 5. So if I divide by 5, divide by 5, what's my new fraction if I divide both of those by 5? 1 over -4, yep. Good. Now move on to your r's. What do I need to do with the r's? Not yet. Subtract them. Yep, we have powers of the same base. We want to subtract. If I flipped them, what would happen to that r squared? It would turn negative, right? So we wouldn't get anywhere. So we want to subtract first. So we have r to the -3. I'm going to write off to the side. R to the -3 minus 2. What's my new exponent? R to the -5. And then I have that over 1. Okay. Let's move on to the t's. What do I do with my exponents? t to the 4 minus 7. T to the negative 3, good. And then what can I do with the u to the negative 5? Flip it to what? U to the 5 over 1. Good. Is there anything else I can do to simplify? Look at the negative 1/4. Can I do anything with that? Nope. So I'm just going to rewrite. What about that r to the negative 5? Flip it to what? Yep, make my exponent positive. What about the t? Same thing, 1 over t to the 3rd. What about u? Keep it. Good. Now I've simplified. Do you agree that I simplified them all to their simplest form? Now I just need to put it all back into one fraction. Okay, what do I have on the top? U to the 5th. And then what do I have on the bottom? That's it, right? So that was putting all the properties you just learned today all together into one. Okay. Notice how I took everything one step at a time. Sooner or later, you're going to get comfortable and you're not going to have to do that. Okay, but I highly advise doing that for now. Okay?